Hello, welcome to all. I am Sachin Sambhaji Patil. I welcome to all of you for this session. So in this session, we are going to see Class B power amplifier. So as we know, the power amplifier, it is classified into the Class A power amplifier. First is that, second is their Class B power amplifier, third is their Class C power amplifier, and fourth is their Class AB power amplifier. Okay, so Class A power amplifier, operating point of transistor lies on center of DC load line. So it is operating for both half cycle, positive cycle and negative half cycle. Class B power amplifier, operating point of transistor lies on x-axis at the bottom of DC load line, and Class C power amplifier, operating point of transistor lies below x-axis. Class AB power amplifier, operating point of transistor lies on center of DC load line and in between the x-axis. It is for Class AB power amplifier. So it is important, and in this lecture we are going to see, in this session we are going to see Class B power amplifier. So Class B power amplifier, as we know that a power amplifier means which amplifies or increase the strength of input signal, increasing the voltage level of input signal. It is the power amplifier. Is referred as Class B power amplifier if the output signal is obtained only for one half cycle period of the input AC signal. It is the Class B power amplifier. So transistor conduct only for one half cycle of input signal. A collector current flows only for 180-degree signal, and Q point, operating point of transistor, quotient point, is adjusted in the cutoff region on the x-axis. So as you know, in the Class B power amplifier, it is operating for only positive half cycle of input signal. So during negative half cycle of input signal, the transistor will be in cutoff region, it will be in the offset. So only during positive half cycle of input signal, transistor will be in the on state. So negative half cycle, transistor will be in the cutoff region, it will be in the off state. So Class B power amplifier, which is working for only positive half cycle of base current. So Class B power amplifier, if the output signal is obtained only for one half cycle period of input AC signal, okay, because only working with positive half cycle of input signal. So in the Class B power amplifier, the coordinates which lies Q point, which is lies on the x-axis, having the coordinates VCC, 0. So there is which is having the Q point coordinates, we are getting VCC, 0, and because we are getting it is on the x-axis, the efficiency of actually what is happening, operating point of transistor Q point, which is lies because there is a y-axis will be 0. Okay, yeah, actually that should be important. Okay, here should be 0, y-axis is 0, so 0, VCC. So it will be 0, VCC. 0, VCC, y-axis will be 0. We are getting Q point on the x-axis. So here we are getting, that is the Class B power amplifier. Okay, so Class B power amplifier, there is the, we are getting, okay, 0, VCC, because y-axis will be 0 and operating point will be VC is equal to VCC. Y-axis will be 0. Okay, so efficiency of Class B power amplifier, it is the 78.5%. Transistor remains in the active region only for positive half cycle of input signal, it is working. During negative cycle of transistor, it will be remaining off state. Collector current is only for positive half cycle of input signal. So this is table. So during positive half cycle, what is happening? During negative cycle, what is happening? So during positive half cycle of base current, transistor is in on state, remain in active region. During negative half cycle of base current, transistor will be in off state, it will be remaining cutoff region. Okay, so transistor during positive cycle, transistor is in on state, active region. During negative half cycle of base current, transistor will be in off state, it will be in cutoff region. So Class B power amplifier, so there is output characteristic. So output current, collector current versus VCE, collector emitter voltage, And if you know VCC minus ICRC minus VC is equal to 0, IC is equal to VCC upon RC, we are getting. So actually what is happening in the output equations? So if you, as we know, the what are the output equations we are getting here, I will explain. So what is happening here? We are getting output equation VCC minus ICRC minus VCE is equal to 0, and after when we put here, that is the IC is equal to VCC upon RC. When VC is equal to 0, so when VCE is equal to 0, so we are getting IC is equal to VCC upon RC. Okay, we are getting RC, and when IC is equal to 0, VCE is equal to VCC. Okay, it is happening. So because of this, we are getting two points, point A, point B. When IC is equal to VCC upon RC, so this is nothing but this is point A, and when IC is equal to 0, if you put in this equation IC is equal to 0, we are getting VC is equal to VCC. And in this equation, if you put here VC is equal to 0, we are getting the IC is equal to VCC upon RC, and when you put here IC is equal to 0, VC is equal to VCC. So we are getting this is point A, this is the point A, we are getting on the y-axis, point on y-axis, and we are getting VC is equal to VCC, point on x-axis. And after joining this point A, point B, we are getting DC load line. If Q point, operating point, quotient point of transistor lies on center of DC load line, class A power amplifier. If operating point of transistor lies on x-axis, class B power amplifier. If operating point of transistor lies on below x-axis, class C power amplifier. If operating point of transistor lies on center of DC load line, in between center of DC load line and in between x-axis, there is a class AB power amplifier. So during class A power amplifier, if operating point of transistor on the center of DC load line, the transistor is operating for both half cycle. During positive half cycle of input signal and also during negative half cycle of input signal, transistor is working, it is operating. And class B power amplifier, during positive half cycle of input signal, the transistor is operating. Okay, during negative half cycle of input signal for class B power amplifier, transistor will be cut off region, it will be in off state. So class A power amplifier, transistor operating in both half cycle, positive half cycle and negative half cycle. Class B power amplifier, operating point of transistor it is on the, we are getting it is on the x-axis. Okay, so that's why it is only working for positive half cycle of base current. Negative half cycle, transistor will be in cut off region or off state. Okay, so and in the output collector emitter voltage there is 180-degree phase shift. So this is the, we have seen how we are getting point A, point B. Point A on, we are getting on y-axis, point B on x-axis. After putting this value in this equation, VC is equal to 0, IC is equal to 0, we are getting this. And after connecting point A, point B, we are getting DC load line. So this is the output waveform. This is base current versus omega t. Omega is angular frequency, 2 pi f. Collector current versus omega t. This is collector emitter voltage versus omega t. So as we know, during positive half cycle of base current, we are getting positive half cycle of collector current. During negative half cycle of base current, transistor will be cut off region, it will be in off state. During positive half cycle of base current, collector current, there is an amplification will be take place. IC is equal to beta times IB. So IC collector current, it is a beta multiple of base current. So we are getting amplified output signal. And during positive half cycle of base current, we are getting positive half cycle of collector current, but it is amplified. IC is equal to beta into IB. And negative half cycle of collector emitter voltage, because there is 180-degree phase shift in the output voltage waveform, and negative half cycle of base current, we are not getting any output voltage. So transistor is in the on state during, so here a transistor, it will be in the on state during in this for positive half cycle of base current, and transistor will be in the off state during negative half cycle of base current, because during positive half cycle of base current, transistor will be in active region, so it will be in on state, and during positive cycle it will be for active region, on state of base current, and during negative cycle of base current, transistor will be in the cutoff region, it will be in the off state. So what are the different advantages? It is having the higher efficiency 78.5%, zero power dissipation under quotient condition, impedance matching with the load is there, impedance matching with the load. Second, harmonic component get automatically cancelled. Harmonic means unwanted signal, unwanted noise which is present in the given signal, it is absent, it is automatically cancelled. High efficiency is there 78.5% and zero power dissipation under quotient conditions. So disadvantages is there, crossroad distortion is present in the output waveform. This is the disadvantage of class B power amplifier. Application is there, audio frequency amplifier, radio, CD player, audio system, audio frequency amplifier in televisions, and public address system. So these are the different applications of class B power amplifier. Audio frequency amplifier also, which are used in radio, compact display, audio systems, and in television also is required. Class B power amplifier. Only disadvantage is that crossroad distortion can take place. So this is very important. You have to just understand this load line. So output current versus output collector emitter voltage. The Q point, operating point of transistor, lies on the x-axis. During positive half cycle of base current, we are getting positive half cycle of collector current. Because transistor, it will be in the active region, it will be in on state. During negative half cycle of base current, transistor will be in cutoff region, it will be in off state, and we are not getting collector current. And we are getting 180 degree phase shift in the collector emitter output voltage waveform, 180 degree phase shift, and we are getting, this is the output characteristic like this. So Q point lies on x-axis, so that class B power amplifier, it is only working for positive half cycle of base current, and during negative half cycle of base current, it will be in off state. So this table is very important. During positive half cycle of base current, transistor, it is in on state, remain in active region. During negative half cycle of base current, transistor, it is in off state, remain in cutoff region. So this is very important table, you have to remember. And this you have to also remember, this is the some collector current only flows for 180 degree signal, input signal. Transistor conduct for one half cycle of input signal. So we can see here in this figure, output characteristic. During positive half cycle of base current, only transistor, it is the where collector current we are getting only positive half cycle of base current. Because transistor, it is in active region, it will remain on state. During negative half cycle of base current, transistor, it goes in cutoff region, and transistor will be in off state, and we are not getting collector current here. So we are getting collector current only during positive half cycle of input signal base current. So IC is equal to beta multiple of IB. So IC is equal to beta into IB. So collector current, it is a beta times multiple of base current. If base current it is in microampere, we are getting collector current, it is in milliampere. Because beta it is suppose 100, 1000, depends upon that we are getting collector current. IC is equal to beta multiple beta times IB. IC is equal to beta into IB. But there is a output voltage, there is 180 degree phase shift. We are getting only negative half cycle during positive input signal or collector emitter voltage, and we are not getting another half cycle. So this is 180 degree phase shift, which is shown here in the output voltage waveform. And class B power amplifier only operating for positive half cycle of base current, and during negative half cycle of base current, transistor will be goes in cutoff region, it will be in off state. So it's very important. So actually today we have seen the class B power amplifier, which is having the efficiency 78.5%, and class B power amplifier, which is only operating for positive half cycle of base current, and positive cycle of base current. During negative half cycle of base current, transistor goes in cutoff region, it will be off state. So you have to remember, because Q point of transistor is on center of DC load line in class A power amplifier. In class B power amplifier, Q point will be on the x-axis. So during positive half cycle of base current, transistor will be in on state. During negative cycle of base current, transistor will be in off state. So here is class B power amplifier.